We're going to go over how to create a population mean confidence interval using a distribution. A confidence interval for a population mean is created like this. You take the sample mean, then you plus or minus the margin of error. So you have a lower bound, which is a sample mean minus the margin of error. And you have an upper bound, which is the sample mean plus the margin of error. So remember, a confidence interval is estimating the population parameter, which is the population mean in this case for this phase. And we're going to use the sample mean to estimate it, but we're not really sure exactly what it is. So we have to put a margin of error on it and say, we think the population mean is between these two numbers, which is a lower bound and upper bound. So you can say something like this: I estimate the population mean of whatever variable you're talking about to be between this number and this number, which is the lower bound and the upper bound. So you know the sample mean is. What's the margin of error? How do you get that? Well, it's based on two things: the confidence level, which determines the critical z-value that I have to use. We'll talk about the confidence level in a minute. Then also the standard error, which is the standard deviation of the sample means, just how much you expect the sample means to vary by chance. We calculate this using the population standard deviation, if you know it, for the z distribution, which is this video, and the sample size. So the margin of error is based on the confidence level. How confident can you be in your estimation, basically? And the standard error. And the standard error is based on the population standard deviation and the sample size. And you do a z confidence interval. And we'll do a t one in the next video. So what is a confidence level? So here is probably the most simplest way I can put it. If you look at this picture on the right, in the middle we have this line that represents the population mean. So we'll just say it's 80. And say we create a confidence interval, and say by chance our sample mean is actually 80 as well. So for that first sample we get a x bar of 80. And then our margin of error is 10. So we do plus or minus 10. So this could be between 70 and 90, right? And 80 is in the middle. But then the next time we do a sample, we get a different sample mean, and say that one is 75. So we do plus or minus 10, so we get 85 to 65. But notice in both of those, even though they have different lower bounds and upper bounds for those two confidence intervals, they both contain the true population mean, which is 80. And say we did a simulation, right? This isn't what we do in real life, but if we did a simulation, then you'd expect that 90% of the confidence intervals contain the true mean. And so if you had 10 samples with the same sample size and you created 90% confidence intervals, you expect that 9 of them would contain the true population mean. So 9 out of 10, 90%. And the confidence level is about the long run, and it's not about one particular confidence interval. So you can't really know if your confidence interval has the population mean in it when you just calculate one, which is what you're going to do. But this is just what that level means and what it would mean if you did a simulation. So I kind of explained what a confidence interval is and sort of how you get it, calculate it, but we'll go over the specific steps now, the specific formula. So remember I said it was a sample mean plus or minus this margin of error. And the margin of error now, I'm going to tell you what that is. It's the critical z-value times the standard error. And the standard error formula, if you remember, is the population standard deviation divided by the square root of n. So you can think of the formula that way. If you kind of put it all together, it also is like this. The sample mean plus or minus the critical z-value times the population standard deviation divided by the square root of n. So I'm just kind of putting things in there to make one big formula. So your lower bound is going to be the sample mean minus the critical z times the standard error, which is the population standard deviation divided by square root of n. And similarly the upper bound, but we're going to add that last part. Okay, so you can think of it either way. I'm just writing the formula different ways, so just do whatever way you like. And so how do you get the critical z's? Well, you can look it up in the table and you do that, but I'm just going to give them to you. So here are very common confidence levels, and you're probably not going to have any other one besides this. I won't give you any other ones besides this in this class, and if you're in psychology, it's usually one of these three. So if you have a 90% confidence level, you're going to have a critical Z of 1.65. If you have a 95% confidence level, you're going to have a critical Z of 1.96. And if you have a confidence level of 99%, you're going to have a critical Z of 2.58. These are the most common. Now let's go over an example of how to use the formula and to create a confidence interval. So it says create a 90% confidence interval for a sample mean of 80 exam points. The population standard deviation of exam scores for this class that you got the 80 average in is 6. Not really this class. The number of exam scores is 36. So you sampled 36 students and got an average of 80. And so our confidence level in the problem was 90%. So we're going to have a critical Z of 1.65. Let's just write these down somewhere. Okay, so the first step is to check the central limit theorem, or we cannot use the standard error that we had. You can't use that formula from the central limit theorem if it's not true. So you need to either have a normal population or a sample size of 30 or more, or you could have both listed in the problem. We have a sample size of 36, so that first bullet point is okay. Doesn't say anything about a random sample, but we're going to relax that assumption for pretty much everything because you never really have a random sample, which I talked about earlier in another video. But hopefully your sample is unbiased when you do real research. Then the second step is to find the standard error, so we can use that formula. And we have 6 as the population standard deviation, and we divide that by the square root of n, which is 36. That's the sample size. And we have 6 divided by 6, which equals 1. Then find the critical z from that table, and it is 1.65. Then you want to take the critical z and times it by the standard error that we found, and that's 1.65 times 1, which equals 1.65. Then you want to find the lower limit, which is just a sample mean minus the margin of error. So we're going to take 80, which is the sample size, minus 1.65. We get 78.35. And then find the upper limit, which is almost the same thing, but we're going to add the margin of error, which is 80 plus 1.65, which is 81.65, and then just interpret the confidence interval. So anything that is underlined is kind of what you fill in. The other part should stay the same or about the same from each problem that you do. You can write it a little bit different, but that will be the basic formula for the sentence. So with 90% confidence, I expect the population mean of exam scores, whatever your variable is, to be between 78.35, which is the lower bound, and 81.65 points, which is the upper bound. And I also put the units so we know what we're talking about.